Okay, good morning, everyone. I'm very glad to be here, and let's expose a little bit what we have done in the last few months with our R&D working to introduce, improve enhancements on the way we are offering LoRaWAN to this great ecosystem. So let's start with the two pillars that are really driving all our actions, okay? They are exposed here. It's all about simplification. We really want to make much easier the and shorter the development cycle of our customers. And the second one is targeting lower TCO, okay? So that's also something that is very important in order to help the ecosystem to expand the market. So those are the two pillars that are driving our roadmap, have been driving our roadmap, and let's say justifying all the innovation that I'm going to show you in those few minutes. And those are also the kind of lighthouses that are driving our future roadmap. So let's start with the kind of what are the topics, okay? So number one, we are introducing a LoRaWAN stack that can be fully embedded into one of our devices. Number two, we are introducing the possibility to lower the cost of network deployments with one-channel hub, and we'll say how this, what it's justifying this new reference design. And we are enhancing LoRa Edge, so our geolocation services that are available within our LoRa Edge family. And last point, it's we are offering a broader tools in the way we propose LoRa Basics modem, so the implementation of the stack on the end nodes. So let's start with ModemE. So what is ModemE? So ModemE is a kind of little brother of LoRa Basics modem, and by the way, it's the full name is LoRa Basics ModemE, and is a LoRa Basics modem that has been tailored in order to embed it into the LR1121. So now customers can have the possibility to grab a binary from GitHub in our LoRaNet repository and flash this into the LR1121 and seamlessly enjoy a single SKU LoRaWAN stack running on LR1121. So nothing to do in terms of complexity, okay? And you see there the three main points and kind of value proposition we are offering with this new products. First of all, as I said, we want to accelerate development cycles and reduce the complexity of this development cycle that today stands on shoulders of our customers. Number two is about offering a quick way to monetize value over LR1121. Now, because we are taking the memory footprint of a LoRaWAN stack, it can be between 60 up to 100K of flash, and bringing this into the LR1121. So now customer can have two axes of freedom in the way they want to size the microcontroller. Either they squeeze and let's say, size the microcontroller memory footprint only based on the application firmware. This means lower cost of the microcontroller, or they can use this the memory that we and more, let's say, generally the digital processing power that we are freeing on the microcontroller to put more intelligence. Okay, and this is going to serve also this big axe of more intelligence at the edge that we are seeing in the ecosystem. Okay. Third point is that the plan is to provide a fully certified LoRaWAN certified stack. So now customers leveraging LoRa Basics ModemE can take advantage of this certification done by Semtech and claiming to the LoRa Alliance a certification by similarity, which is a quicker process and also less expensive because removes the need to go through test house process, okay? So those are all the features that are, let's say, available with this LoRa Basics ModemE. As I said, it's a single SKU, all regionals, all additional RFHSS data rate, relay for the end node, so for the relayed node, what the LoRaWAN calls relay TX. But very, very important feature that we are adding in this LoRa Basics Modem E version 2.0 is the possibility to bypass the LoRaWAN stack and still driving the LRM21 as a simple transceiver from the microcontroller. This allows customer to run a proprietary stack on the microcontroller. And so this is a kind of, let's say, easy path to either add LoRaWAN to LoRaWAN proprietary LoRa protocols, let's say, okay, and or bridging LoRaWAN with those LoRa proprietary protocols, okay? So this is an interesting feature that we are making available with this V2 modem. Now, see, those are other features. I would just want to mention the one in the middle of the top. So modem E brings also a power savings for all those use cases where there is a kind of intensive need of Class B operation. Because now everything, all the, let's say, mechanics of the stack managing the Class B operation is done into the LRM21. No need to wake up continuously or host a microcontroller to manage the RX windows periodically for the Class B. So power savings for all those use cases where Class B is a kind of mandatory requirements. And think about FOTA, okay? So customers can save power also with where FOTA is needed very frequently. Now, next innovation that we are bringing, it's available on our booth. I invite you to stop by. We have a demo there. So we realized that there was a kind of missing piece in the way we were offering reference design to enable networks. And this missing piece was about giving the possibility to deploy with a minimum cost small LoRaWAN bubbles needed to manage 5, 10, 15 sensors, okay, for which the full cost of a LoRaWAN gateway was kind of perceived as a prohibitive cost still, okay? So this was limiting the market expansion on our side. And then think about especially houses, okay, so smart homes or small buildings where we know, I mean, we're not gonna, let's say, have a gateway managing hundreds of devices. Maybe 5 devices, 10 devices are far enough, okay? We are seeing demand for LoRa in smart home wherever there is a need to expand the coverage outside, let's say, the standard walls, okay, so in the gardens, or where there are multiple floors where sometimes, okay, other technologies does not work very well. So there is a demand there, and we want to make it, we want to serve this demand with the minimal TCO. So what we are doing is that we are proposing a new reference design that, of course, will have, it's here in the middle, okay? So one channel hub, and is basically based on a single transceiver that can manage a limited amount of nodes. I'm putting there, let's say, 50 devices the most, okay? Because it's operating on a single channel, single splitting factor. Of course, 50 devices really depends on the amount of traffic that it has to manage. So for a very intensive, let's say, activity, maybe 50 is too much. Maybe customer should, I mean, lower it to 20 or 15 devices. But really, depending on the use cases. But here, the market has a tool to offer and enable this, let's say, small LoRaWAN bubbles in a more cost-efficient way. Okay. So now we have here, let's say, the all 4 way we are offering enablement for the network deployments, starting from the relay, one channel hub, and the gateway for indoor and outdoor that I would say moves from the left to the right, sorry, from the right to the left in terms of cost, but also in terms of capacity. Now, big difference between one channel hub and relay is that relay already needs a LoRaWAN coverage because it bridges a LoRaWAN sensor toward a gateway, a LoRaWAN gateway. And relay has been designed, architectured, in order to be battery powered. The one-channel hub can be seen as a really minimum-sized gateway with a minimum capacity, okay? Now, that's the demo that you can see at our booth. So with the standard LoRaWAN sensors, okay? Nothing to do on the protocol of the sensor itself. So I really invite you to stop by and see our demo that is running on the TTI network server. So nothing on the sensor nodes to do in terms of stack adaptation, okay? Which is on the other side needed for the relay. Now, next point, next innovation is about LoRa Edge. I say we are simplifying the utilization of LoRa Edge, and we are also enhancing the accuracy and the performances of the LoRa Edge, of the geolocation, GNSS geolocation. So 3 points there. Starting from the right, we are introducing autonomous mode. So now, in order to get the position, there is no need anymore for downlink assistance messages. So this really removes the need of downlink, which saves cost associated with downlink, but also simplifies the solution itself, okay? Now the device itself can demodulate the real time coming from the GNSS constellations, the rough position coming from the GNSS constellation. So everything is done inside the sensor and sent to our cloud solver, okay? Very important about the autonomous mode. Since now we are enabling the possibility to get real time for the GNSS constellation, we saw this feature very interesting for all those use cases where there is a need to synchronize tightly the sensors, okay, in order to manage the traffic, especially and minimize congestion. One use case that comes on top of my head is the street lighting, okay? So sometimes they implement a GNSS module just for the sake of getting this real time. Now with this autonomous mode, there is no need of GNSS module. So the time synchronization can be ensured by our LoRa Edge in situ, okay? Without even going asking the services of our LoRa Cloud or GNSS solver. Second, in the middle, we have higher accuracy, so improve the accuracy by 25%. So now we can say that we can very, let's say, consistently provide a geolocation that is below 10 meters, which is really addressing the majority of use cases. And for all those use cases that are static, we can even go closer to 5 meters. Not below 5 meters, but closer to 5 meters is something that is achievable with some kind of intelligence in the way multiple scans can be done, okay? Third point is about enhancing success rate. Now we need less satellites in order to make the positioning available. So we reduced the number of minimum satellites from 6 to 5. So really, and this increased also the success rate, which at the end means less power consumption, okay? Last point is in the way we are proposing LoRa Basics modem. So now LoRa Basics modem is available in a broader way to the ecosystem. We started proposing it through our, let's say, the way our evaluation kits are made available. So the first release was with the STM32L4 bare metal. Now we have started, let's say, enriching this offer, adding an L0 implementation, moving also with the Sapphire's implementation. Lucas just mentioned about Sapphire's actions activity we started, okay? So now we have a LoRa Basics modem available under Sapphire on a Nordic microcontroller. We have also ThreadX for over STM microcontroller as well. So we are expanding the way our ecosystem can get this LoRa Basics modem and utilize it into their development. So definitely expanding the way bare metal, RTOS, but also the microcontroller that we can serve, ST and Nordic today, okay? So that's the last, let's say, enhancement in our portfolio that we introduced. Any questions?